So we finished chapter 5 the other day. We only got a few more days left of new instruction. I haven't decided quite how many yet. We're either going to do 4 days of review for the semester test or 6 days. I'm kind of leaning towards 6. So that would make us do new material today, tomorrow, and Monday. And then the rest of the days would be review.
I agree with
That's kind of what I'm leaning towards. Yeah, because 4 days next week, plus only 2 days the following week of review, and then the final 2 days of school are test days. So, that's kind of what I'm leaning towards, is 6 days of review. So that means today, a new lesson, part 1 of 7.3. Tomorrow we'll get part 2. And then Monday we'll get another day of new material. And then that would be it. If we do 6 days of review. We may do 5, we may do 4. Who knows? But you'll find out eventually. Soon enough. So we're kind of jumping around a little bit because I'm just trying to get you some stuff in that you might see in your future math classes. So you might see multiplying and dividing rational expressions. So that's why we jumped from chapter 5 to chapter 7, section 3. So let's jump into it. Let's talk about what a rational expression is. It is a fraction whose numerator and denominator are non-zero polynomials. The domain of a rational expression excludes values that make the denominator 0. Remember, if we have a fraction, we do not want the denominator to be 0. So we have to give specific values that x cannot equal that would make my denominator 0. And we'll look at some examples in a second. A rational expression is in simplified form when its numerator and denominator have no common factors other than 1. So if I have just an original fraction, 6 over 10, what does that reduce down to? Or I guess I should say, is that in simplest form? It is not, because what does it reduce down to? 3 over 5. Same concept with our rational expressions today. We want to write them in simplified form. We want to divide by something, essentially, that they both have in common, the numerator and denominator. Any questions about what a rational expression is? Am I good to move on? Okay, I'll wait a little bit. Okay, let's go ahead and move on. So still talking about simplifying rational expressions. Let A, B, and C be expressions with B not equaling 0 and C not equaling 0 because they're in my denominator. If I have A times C over B times C, they have a common factor of C, right? So those C's would just cancel out to leave us with A over B. Anything over itself is what number? 1. That's why we're able to just cancel stuff out that's in the numerator as well as in the denominator. Because if I'm dividing, that divided by itself is just 1, so that's redundant information, essentially. So it gives us another example of just a numerical fraction. 15 over 65, what are they both divisible by? 5. So that's why they broke it down into 3 times 5 over 13 times 5. They're just showing you that they're canceling the 5s out to leave us with 3 over 13. Everyone good with that? And then they give you an example of a rational expression. We have 4 times x plus 3. And then we have x over x plus 3 times x plus 3. They have x plus 3 in the numerator as well as in the denominator. So those cancel out with each other to leave us with 4 over x plus 3. Same concept as just a regular fraction. Everyone good with that? Yes?
Isn't this pretty much just reducing?
Essentially. We will get into some factoring today. So hope you guys are good on your factoring skills. So we will be factoring to simplify later on. And we're going to multiply some fractions today. Any questions on simplifying rational expressions? Not too bad so far? So still talking about simplifying. Usually requires just 2 steps. The first step is to factor our numerator and our denominator. Second step is divide out any factors that are common to both my numerator and my denominator. So that's what I was talking about just a second ago with factoring. We're going to factor both the numerator and the denominator. Cancel out stuff that's in the numerator and the denominator. That's us simplifying. So on this example, x squared and 7x share a common factor of x. So they factor out an x to get x times x plus 7. X squared can just turn into x times x. So we have an x in the numerator and x in the denominator. Those cancel out. Leave us with x plus 7 over x. Factor, numerator and denominator. Cancel stuff out if you're able to. Rewrite your fraction. Any questions? Can I move on or are we writing? Okay, give you a little bit of time. So you asked if I can cross out the x in the x plus 7 over x.
Yes.
Right? I cannot do that because these are technically 2 terms right here. If I rewrote it as x over x plus 7 over x, then they would cancel in that first term to just become 1. But if we leave it like this, we cannot cancel it out because it technically goes with both of my terms. Does that make sense? Okay. Okay, moving on to an example. Simplify x squared minus 4x minus 12 over x squared minus 4. So what was my first step in my 2 steps that I got to do when I'm simplifying? Do what? Factor them out. So yeah, find a common factor. So let's factor x squared minus 4x minus 12. If you recall from a few chapters back, we create our 2 sets of parentheses. What's my variable I'm dealing with? X, so I've got an x here and an x here. Say what? We're not there yet. What are my 2 signs?
Negative and positive.
One's plus, one's minus.
-8.
Remember, if the sign in front of your c value, here's our c value. If the sign in front of c is negative, your 2 signs are going to be plus and minus. Okay? If it's positive, then they're going to be the same. You just got to figure out if they're both going to be plus, both going to be minus. So if it's a plus sign in front of my c, and then it's a plus sign in front of my b, they're both going to be pluses. It's a plus sign in front of my c, and a minus sign in front of my b, they're both going to be minuses. Okay? But anytime it's a minus in front of my c, they're both, or the one's going to be plus, one's going to be minus. So I'm looking for 2 numbers that multiply to give me negative 12, add to give me negative 4. Once again, if you like the X puzzle better, I did teach you that first. You can use that. So does anyone know it off the top of their head? Negative 6, positive 2. Negative 6 plus 2 gives me negative 4. So those are the 2 numbers I'm looking for. So I get x plus what? 2. X minus 6. Now my numerator is factored. Questions on how I factored my numerator? Now I need to factor my denominator. Does anyone remember how to factor x squared minus 4?
Did x times x minus 4?
Yes, but that doesn't technically help us out a whole lot. Say what? This is a difference of squares. Do you remember how to factor a difference of squares? Take what?
Square root of both.
Take the square root of what and what?
X squared and negative 4.
Very good. So I got my two parentheses still. What's the square root of x squared? So I got an x right here and an x right here. What's the square root of 4? 2. So I've got a 2 here and a 2 here. And then what are my two signs? Plus, minus. And that's how I factor a difference of two squares. Take the square root of each term, put them in their corresponding spots. One sign's a plus, one's a minus. If you forgot how to factor a difference of squares, you could always rewrite it as this and factor like normal. You're looking for two numbers that multiply to give you negative 4, add to give you 0. That's positive 2 and negative 2. That would work as well. Any questions on how I factored my numerator or my denominator?
Are we done?
Not yet,
Oh, okay.
because what can cancel out?
Yeah, X plus 2.
X plus 2 in the numerator can cancel out with the x plus 2 in the denominator. So that leaves me with x minus 6 over x minus 2. Any questions on that? So this would be my simplified expression. Any questions on that? Do you guys remember what it said about the domain? What does it say about my domain? It excludes any x values that make the denominator 0. So let's go look at my denominator. What values of x would make my denominator 0? 2. So x cannot equal 2. Any other values? What? We're just looking at the denominator. Not 1. And remember, we just simplified this expression, correct? So this is technically equivalent to this. So, looking at this denominator, what other values of x would make my denominator 0? Not 4.
X squared. Negative
So we already got 2. Negative what?
4. Negative 2.
Negative 2.
But that would be negative 4.
So if I plug in negative 2, negative 2 squared would be negative 2 times negative 2, which is positive 4.
Oh, 4 minus
4 minus 4 gives me 0.
Oh, okay.
Remember, we don't want 0 in my denominator. If you wanted to write it like this, I'd be okay with that. But sometimes it's not the same number with opposite signs, so you want to be able to do that. Sometimes it could be like 2 and 3.
So it's x doesn't equal negative 2.
Correct. So x does not equal positive 2, x does not equal negative 2, because both of those, somewhere along the lines in here, would make my denominator 0. And I don't want that. So I've got to specify that x cannot equal those values. Does that make sense? Any questions there? Let's move on. Now let's talk about multiplying. Let's say I have these two fractions and I'm multiplying them. Let's talk about regular numerical fractions. 1 over 2 times 4 over 5. How would I multiply those?
Straight across.
Straight across. What's 1 times 4?
4.
4. 2 times 5. And do I leave it like that, or do I always have to reduce my fractions?
Reduce.
Always reduce. What does that reduce to?
2 over 5.
2 over 5. It's the same concept with my rational expressions. We're going to multiply straight across and reduce. That's what this paragraph is pretty much saying. The rule for multiplying rational expressions is the same as the rule for multiplying numerical fractions. Multiply numerators, multiply denominators, write the new fraction in simplified form.
Is that your answer? 2 over 5?
Yeah, that's just an example with a numerical fraction. And then we don't really need this last statement, but it's up there anyways. Similar to rational numbers, rational expressions are closed under multiplication. We're not worried about that right now. We're ready to jump into an example of multiplying rational expressions. After this slide, let A, B, C, and D be expressions with B not equaling 0 and D not equaling 0, because they're both in my denominator. So if I have A over B times C over D, that would just equal A times C over B times D. And then we simplify AC over BD if possible. And here's a nice little example for us. Multiplying straight across. 5 times 6 gives me 30. We're also bringing in our properties of exponents. If we multiply something with the same base, add your exponents. So x squared times x would be x to the third. And then that y cubed is not multiplying by another y, so it stays as y cubed. 2 times 10 gives me 20. The x just comes over. Y squared times y gives me y cubed. So I multiplied. Now I reduce. 30 over 20 reduces down to 3 over 2. They're both divisible by 10. I've got 3 x's in the numerator, 1 x in the denominator. So only one set of x's is going to cancel out. So that leaves me with 2 x's in my numerator. And then all the y's cancel out because there's 3 up top, 3 in the bottom. So we get 3x squared over 2. And they're specifying here x cannot equal 0 because that would make my denominator 0. Y cannot equal 0 because that would make my denominator 0. Questions on that before we jump into our own example? You guys awake? Some of us are not. Am I good to go ahead and move on? Find the product. 8x cubed y over 2x y squared times 7x to the fourth y cubed over 4y. So we're just going to multiply straight across first. What is 8 times 7?
56.
56. X cubed times x to the fourth.
X to the 7th.
X to the seventh. Remember, add those exponents if we're multiplying something with the same base. Y times y cubed. Y to the fourth. Are there any questions how I got that as my numerator? Does that make sense? Okay, 2 times 4. X doesn't have anything to multiply with, so it just comes over as x. Y squared times y. Y cubed. Any questions how I got that as my denominator? I'm going to go with multiplying straight across. Okay, let's start simplifying. What's 56 divided by 8? 7. What would that make my denominator when I divide those? 1. 7 over 1. Do I have to write that 1? I do not. So up top, I've got 7 x's. It would be x to the 6th because, yep, well, no, I do not. I'm just showing y'all how it works out. I've got 7 x's up top, 1 in the bottom. Only one set of x's cancels out, right? So like we said, we're left with 6 x's, which would be x to the 6th. So do I have any x's in the bottom still? In the denominator? I do not because it got canceled out. And then once again, I've got 4 y's up top. 3 y's in the denominator. How many y's or how many sets of y's are canceling out? 3. So that leaves me with how many up top, how many in the bottom? 1 up top, 0 on the bottom. And is that everything? So I don't even need that fraction bar because I would just have 1 down there. So this is my simplified expression after I found my product. What do I need to specify though? What can x not equal in this case? 0. If I make x 0, that makes my whole denominator 0. What about y? Can y not equal anything, or can it equal everything? Cannot equal 0 as well. So once again, if I plug 0 in for y, it makes my whole denominator 0.
Is that an answer too, or are you just
That's-
putting that as extra?
That's part of my answer, because I've got to explain that to people who don't necessarily know the original problem.
So like if it says explain on the question, you'll have to put that, or
We'll
you
have to
just
put
do
like
that
x
anyways.
can equal.
You need to put that whether it says to explain or not.
Okay.
That needs to be part of your answer. Okay? Does everyone understand that? That's you letting people know, hey, x cannot equal 0 for this problem. Hey, y cannot equal 0 for this problem. That would give me a 0 in my denominator. Okay? Questions on this example? Last example for today. Right here. Looks a little different than my last one. Find the product, 3x minus 3x squared over x squared plus 4x minus 5 times x squared plus x minus 20 over 3x. It's a lot. Anyone have any thoughts of what I might be able to do first? Not yet.
Would you cancel? Would you like separate them and
What do you mean separate them?
like take the 3x minus 3x squared and then
What do we call that? Starts with an F, right? Factoring. Let's go ahead and factor first, right? So what does my first numerator have in common? What do those terms have in common? 3x minus 3x squared.
x? So we're gonna just grab 3x.
What'd you say, Malia? Not negative x. They do have a 3 in common and an x in common, right? So 3x times what would give me 3x? 1. 3x times what would give me negative 3x squared?
X.
Negative x.
Negative x. And that'd be it factored.
And the bottom, wouldn't the bottom one be x plus 5 or x plus 1?
You said what?
X plus 5 or x minus 1.
X plus 5, x minus 1. Does everyone agree with that?
And one of those
Because we're looking for two numbers that multiply to give me negative 5, add to give me 4. 5 times negative 1 is negative 5. 5 plus negative 1 gives me 4. So that would be my factored form of my denominator. Everyone good with that one? Any questions on factoring so far? Let's look at my second numerator.
Wait,
x plus 5 or x minus 1.
would the 1 minus x and the x minus 1 not cancel each other out, or because they're
They're not the same, are they?
okay?
So x squared plus x minus 20. I got my two sets of parentheses.
X plus 5.
And our variable is x. What are my two signs? One's a plus, one's a minus. Now I'm looking for two numbers that multiply to give me negative 20, add to give me 1. 5 and negative 4. 5 times negative 4 gives me negative 20. 5 plus negative 4 gives me 1. So it's x plus what? 5x minus 4. Questions on that numerator?
Wouldn't it just be 3x?
Yep, 3x cannot be factored. So we just keep it as 3x. Questions on how I factored it all? Okay, now we can multiply. We're multiplying straight across, right? Do you guys think I'm going to multiply everything out and undo all the work I just did?
Wouldn't you
No.
cancel things out?
Say what?
Wouldn't you cancel things out?
Let's go ahead and multiply and then cancel. Okay? You could cancel before you multiplied, but let's go ahead and multiply first. I'm just going to rewrite it like this. Just all of them right next to each other. Just like that. Everyone okay with that? That's just multiplying straight across. Now what cancels?
X plus 5.
X plus 5, I have that in the numerator as well as the denominator.
And then 3x.
3x and the 3x. Those cancel out as well. 1 minus x looks pretty similar to x minus 1, doesn't it? Is there something else? You guys kind of were hinting at it earlier that I could factor out of that top factor to make it x minus 1? A what? Negative 1. Is that what you were saying earlier? Okay. So we could factor out a negative 1. Because if I factor out a negative 1 from 1 minus x, negative 1 times what would give me 1?
Negative 1.
Negative 1. Negative 1 times what would give me negative x? X. So that'd be negative 1 times x minus 1. Does everyone see that? So I'm going to go fix that up here. I can factor out this negative 1 up here. Negative 1 times 3x. And this is x minus 1. And this is x minus 1. I have this negative 1 that comes along with it. Does everyone see that? Everyone okay with that? Some of us look confused. Question? Because what happens now with those x minus 1s? They can cancel out. That is why we did it. Does that make sense? Now it is going to be in simplest form after I write my new expression. We just missed that negative 1 at the beginning. Okay.
X minus 4.
Yes. That'll be our simplified expression. Because we have negative 1 times x minus 4 left. And what can I do with that negative 1? Huh? Distribute. So I get negative x plus 4. That would be my simplified expression. Any questions there? Okay, what do I need to specify though? Is there anything that x cannot equal? What can x not equal? X cannot equal what? Negative 4? No, because that's in my numerator. Remember, we're looking at denominator. 0. X cannot equal 0. If x is 0, 3 times 0 would give me 0. 0 times everything else would give me 0 in my denominator. So it cannot be 0. What else can x not equal?
You said it can't be negative 4 because that's on the numerator?
X can be negative 4.
Okay.
So I'm not going to say x cannot be negative 4. I know it's kind of confusing, but what else? What other x value would give me 0 in my denominator? If you don't know, here's a little trick. You can set each factor in your denominator equal to 0. So 3x equals 0. Divide by 3. So 3x equaling 0, x would have to be 0 to make it 0. So that's why we said x cannot equal 0. Okay? Now let's set x plus 5 equal to 0. How would I get x by itself? Subtract 5. X equals negative 5. So what can x not equal? Negative 5. So, doing the work in your head, what else can x not equal? X cannot equal 1. Everyone good with that? If x is any of those values, my denominator would be 0, and we don't want that. Questions on example 3? Can I move on? to our assignment. Page 384. Numbers 3 through 18 all. This will be due Monday, May 17th on Canvas. Any questions about that? Any questions about my notes before I end the recording?